Hello dear friends, welcome to the lecture of integral transforms. In this lecture we shall study some multiple choice questions on beta and gamma functions, Laplace transform and Fourier transform and their applications. So here I have written a few questions. I will suggest you to take a screenshot of this and write the answers yourself, then verify the answers. The instruction is choose the correct alternative. 4 alternatives are given for each question and we have to select one which is correct. The first question is the value of the integral 0 to 1 x power 4 into 1 minus x to the power 3 dx is which one? So this integral can be expressed in the form of gamma function. So we know the definition of gamma function is, I shall write here, gamma of n is equal to integral 0 to 1. So it is not in terms of gamma function, but it is in terms of beta function. Gamma function's definition is integral 0 to infinity e power minus x power n minus 1 into dx. But you see the integral is from 0 to 1 and therefore we have to use the definition or of beta function. Beta function is beta of m and n is integral 0 to 1 x power m minus 1 into 1 minus x power n minus 1 into dx. Now see, this is of the form, this form, beta function form, and we can write 4 as 5 minus 1 and 3 as 4 minus 1. So therefore this will be equal to beta of 4 plus 1, that is 5, and 3 plus 1, that is 4, beta of 5 and 4. Because this is written as 5 minus 1 and this is written as 4 minus 1. So therefore this is beta of 5 and 4, and but the value is given in this form, and therefore we have to use again the relation between beta function and gamma function. So this is to be converted into gamma function form, and that we have it as beta of m into n, beta of m and n is gamma of m, gamma of n into gamma of n divided by gamma of m plus n. And now this will be, m is 5, so this is gamma of 5, gamma of 4 divided by gamma of 5 plus 4, that is gamma of 9. And we know gamma of n plus 1. Gamma of n plus 1 can be written as n into gamma of n, or that is if it is integer, positive integer, then it is n factorial. So therefore gamma of 5 will be, this can be simplified as gamma of 5, that is 4 factorial. One number is reduced, so gamma of 5 is 4 factorial, gamma of 4 is 3 factorial divided by gamma of 9 is 8 factorial. And this further can be simplified, and that gives 4 factorial, 3 factorial is 6, or we can write 3 into 2, and 8 factorial can be reduced as 8 into 7 into 6 into 5 into 4 factorial. And further you see this 4 factorial can be cancelled, 6 cancels, and what remains is 1 upon 8 into 7 into 5. So that is 8 into 5 is 40, 40 into 7 is 280, and therefore this is the correct alternative. That means here we have used the beta function. Beta function, this expression is equal to beta of 5 comma 4, and that written in terms of gamma function. Gamma function result is used as gamma of n plus 1 is n factorial, and it is calculated. Now next is the value of gamma of 5 by 2 is which value? For this purpose we can use the same result, this result, and here n is 5 by 2, not integer, then we must use the first form. If n is positive integer, then gamma of n plus 1 becomes n factorial, and if it is not positive integer, then we should use this form. Gamma of n plus 1 is equal to n into gamma of n, and therefore what will be gamma of 5 by 2? Gamma of 5 by 2 will be equal to, reduce one number by 1, that is 5 by 2 minus 1. 5 by 2 minus 1 we know is 3 by 2. So, this is 3 by 2 into gamma of 3 by 2. Again, gamma of 3 by 2 can be reduced using this same result, and that will be 3 by 2. 3 by 2 minus 1 means 1 by 2 into gamma of 1 by 2. And we know that gamma of 1 by 2 is root pi. So, therefore, this will be 3 by 4 into root pi, and thus the answer is 3 root pi divided by 4. A is the correct answer. Next, the Laplace transform of f of t is which of this? Actually, this is the definition of Laplace transform, and the definition of Laplace transform we have is, see, the different integrals are given. Only the change is this is kernel of Laplace transform e power minus st, or the definition of Laplace transform is integral 0 to infinity e power minus st into capital F of t dt. So, this is the definition of Laplace transform, and therefore, the correct alternative here is, you see, this one. This one is the correct alternative. It is direct definition of Laplace transform. The value of L of cos, hyperbolic cos, it is cos h of at means hyperbolic cos at is. So, that is a formula, standard formula. After this defining Laplace transform, we have obtained the Laplace transform of some standard functions, that including 1, then e power at, etc., t power n, and hyperbolic functions also we have obtained Laplace transform, and the formula is L of hyperbolic cos at is s divided by s square minus a square, and thus this is a formula, and therefore, the correct alternative is D. Next is the Laplace transform of 1 over a square into 1 minus cos at is, which is the Laplace transform of the function. For that purpose, we can use the linearity property of Laplace transform, and see, the fifth is L of this a square is constant, so it may be written outside the transform. So, it will be 1 upon a square into L of 1 minus cos at, and that is 1 upon a square. This again can be written as L of 1 minus L of cos at. L of 1 is 1 over s, 1 upon s minus, and L of cos at is s divided by s square plus a square. These are the formulae for Laplace transform of 1 is 1 by s, Laplace transform of cos at is s upon s square plus a square, and that can be simplified. It is 1 upon a square into bracket, cross multiply, take the LCM as s into s square plus a square, and see, the numerator will be s square plus a square minus s square, that is a square, and therefore, this a square cancels, and what remains is 1 upon s into s square plus a square. 1 upon s into s square plus a square. But the alternatives 1 upon s upon s square plus a square whole square, etc., and therefore, you see, this alternative we have to correct. It is s into s square plus a square, s into s square plus a square, and that is the correct alternative. So, here it is to be corrected. Next is the Laplace transform of t power 3 by 2 is, that is using the formula for L of, we have the formula L of t power n, general is gamma of n plus 1 divided by s to the power n plus 1. If n is not positive integer, n is not integer, then we have to use this formula. If n is integer, then it is n factorial. The value of gamma of n plus 1 is n factorial divided by s to the power 3 s to the power n plus 1. So here for this t power 3 by 2 we have to use the first formula, and that is L of t power 3 by 2 will be equal to gamma of 3 by 2 plus 1 divided by s to the power 3 by 2 plus 1, or that is 3 by 2 plus 1 we can reduce using the reduction of gamma function, and we know the reduction of gamma function is gamma of n plus 1 is equal to n into gamma of n, and therefore this value is to be written as 3 by 2. 3 by 2 into gamma of 3 by 2, again that is reduced 1 by 2 into gamma of 1 by 2 using this formula divided by s power 3 by 2 plus 1 is 5 by 2. So that is s to the power 5 by 2, and this will be gamma of 1 by 2 is root pi, therefore this will be 3 by 4 root pi divided by s to the power 5 by 2, and thus the correct alternative is the first one. A is correct. Next, the Laplace transform of t square e power minus at is, which is the Laplace transform of that. And for this purpose, we shall use the shifting theorem, first shifting theorem of Laplace transform. What is the theorem? If L of e power at f of t is equal to f of s minus a. What is fs? Fs is Laplace transform of f of t, and therefore here what is to obtain this Laplace transform, we should consider f of t as t square, and so take L of t square. Now what is L of t square? Using the earlier formula L of t power n, here it is integer, and therefore we can write as 2 factorial divided by s to the power say 2 plus 1, that is cube, s cube, and that will be 2 divided by s cube is the Laplace transform. And using this, therefore L of e power minus at, e power minus at into t square will be equal to, this is fs here, and that is to be replaced by s is to be replaced by s minus a, but here minus a is negative of a, negative in place of a here is negative a, and therefore this negative a becomes positive, and thus this will be f of s plus a. And what is f of s plus a? If fs is 2 divided by s cube, f of s plus a will be 2 divided by s plus a cube, and thus the correct alternative is here B. Next is if L inverse of fs, that is inverse Laplace transform. Inverse Laplace transform of small f of s is denoted by capital F of t, then L inverse of f of s minus a is what? So this is actually a theorem, first shifting theorem of inverse Laplace transform, which depends exactly on this. See, if you take L on this side, it will be L inverse of f of s minus a. From this we can write L inverse of f of s minus a. This L is taken on this side, it becomes inverse operator. L inverse of f of s minus a is equal to e power at f of t, and therefore the correct alternative is e power at f of t, that is first. Next one, again the inverse Laplace transform of f of s is a capital F of t, then L inverse of f of as is which one? So for this purpose we can this is actually a change of scale property for inverse Laplace transform, and the result is direct, but we may use the result from the change of scale property of Laplace transform. We have L of f of at is equal to 1 upon a small f of s upon a. So this is the result, and therefore if you take a on this side, or first take the inversion, therefore f of at is equal to L inverse of. So the for shifting theorem or change of scale theorem for inverse Laplace transform is proved with the help of all the results of inverse Laplace transform are proved with the help of the corresponding result of Laplace transform. So we have considered the change of scale property for Laplace transform, and we are obtaining change of scale property for inverse Laplace transform, and this 1 by a can be written outside and then taken on this side. So this becomes L inverse of f of s upon a is equal to a into f of at. So this is actually the result, but here we want the result for f of as, and thus that means we can replace 1 by a by b. So put 1 by a is equal to b, then it will be L inverse of f of bs is equal to, this is 1 by b, 1 by a is b, therefore a is 1 by b, f of capital F of a is 1 by b into t. Now we can change b by a, then that becomes change b to a. The result will be L inverse of f of as is equal to 1 upon a f of capital F of t upon a, and therefore the correct alternative is here the last one. So now we will consider the next questions. These are the next questions. Again, I would like to suggest you to take a screenshot. First write your answers and then verify them. The 10th question is, if Laplace transform of f of t is equal to small f of s, then Laplace transform of t power n f of t is equal to which of the following? So this is actually a theorem of multiplication by powers of t, and that the answer is minus 1 power n minus 1th derivative of Laplace transform of f of t. So therefore the correct alternative is minus 1 power n. Here the derivative is first derivative, here it is n minus 1th derivative of f of s, and here nth derivative of f of s, but it is actually n minus 1th derivative of f of s, and therefore this is the correct choice. It is a theorem that we have proved. And the next is, if fs is Fourier transform of capital F of x, then the Fourier transform of f of x minus a is. So this is the theorem, shifting theorem on Fourier transform. Now we are considering Fourier transform. This is for Laplace transform. Fourier transform of f of capital F of x is denoted by small f of s. Then the Fourier transform of this capital F of x minus a. This is a shifting theorem, and it is e power minus isa into f of s. So therefore this is the correct alternative. So these are the theorems on this is theorem on Laplace transform, this is a theorem on Fourier transform. The next is, if fs is the Fourier transform of capital F of x, then Fourier transform of fx into cos ax is. So this is also a theorem which is a modulation theorem. So this 12th is modulation theorem. Fourier transform of capital F of x multiplied by cos ax is half f of s minus a, or actually it is the average of f of s minus a and f of s plus a, and that is, this is the correct alternative. Half f of s minus a plus half f of s plus a. The next is the cosine transform of f of x is equal to e power minus x is which of the following. Now we shall consider the Fourier cosine transform. Actually, the Fourier cosine transform by definition is denoted by, we denote it by Fourier cosine transform of f of x, capital F of x, or that in simple form this is f of cosine transform, and is integral 0 to infinity e power, it is the function is f of x is e power minus x multiplied by cos sx into dx. So this is the Fourier cosine transform of e power minus x, or that we can write here e power minus x. If it is fx, then here it will be fx into cos sx, and now we have a formula for this. So we can use the formula 0 to infinity e power minus ax cos bx is equal to into dx is equal to e power, it is a divided by a square plus b square. Now this is a formula from integral calculus, you may verify this, and therefore by using this formula, now what is a here? A is 1, and therefore the result here will be this is equal to the above transform will be equal to a is 1. So 1 divided by a is 1 means 1 square plus b is s, compare this with, so 1 upon 1 plus s square, and thus the correct alternative is B. Next is if d2y by dt square plus y is equal to 0, this is a differential equation. Application of Laplace transform to differential equation, and if y is equal to 1, dy by dx is 0 when t is equal to 0, then what is the value of y? Actually there is no need to solve this equation. See, this differential equation is given, and we have to solve this equation using Laplace transform, but the answers are given here, so only we need to verify which will be the answer, and that value of y must satisfy the differential equation, and the value of y should also satisfy these initial conditions. So therefore this will be, now see, if you consider first value of sine y, if y is equal to sine t, if y is sine t, then what is the value of y at 0 when t is 0? Sine 0 is 0, but it is given as 1. So therefore the first is not the answer. Second, tan t, again we know that when t is 0, tan t is 0, but y is 1, that is given. So this will not satisfy the condition, initial conditions. It must satisfy the initial conditions plus the differential equation, then it will be the solution. So it does not satisfy the initial condition, no need to check the differential equation. Now what about cos t? So we have cos 0, y is equal to cos t, then we have y is equal to y at 0 is equal to cos 0, and that is 1. And what is dy by dt? Dy by dt is minus sin t, and its value at 0 is equal to 0. So therefore these two conditions are satisfied by cos t. Whether the equation is satisfied by cos t, derivative of cos t is minus sin t, and derivative of minus sin t is minus cos t. So the differential equation becomes minus cos t plus cos t, and that is 0. So that equation is also satisfied, and the initial conditions are also satisfied by cos t, and therefore this is the correct alternative. Further is Fourier sine transform of f of x is equal to 1 by x. Now the definition of sine transform similar to cosine is f sine transform fs of s is equal to, or the different notations can be used 1 by x. Fourier sine transform of 1 by x is equal to integral 0 to infinity fx, that is 1 by x, into sine sx into dx. Or this is an improper integral in a particular form, sine sx divided by x, and its value is earlier obtained and known to be pi by 2. So, using Laplace transform also we have evaluated this integral, and that is pi by 2. So, therefore, the correct answer for this is pi by 2. The next is Fourier sine transform of x is, here I have listed two problems. Fourier sine transform of fx is equal to x is which one, and next is Fourier cosine transform of fx is equal to x is which one. Sine and cosine transform of fx is equal to x we shall find out. So, if we write this sine transform, then Fourier sine transform of x is x into sine sx, and that we shall denote by fs. And Fourier cosine transform is denoted by this notation. C stands for cosine, S stands for sine, and this notation is again Fourier cosine transform of x is equal to integral 0 to infinity x into cos sx into dx. Now, we shall consider another transform which we will denote by fs, and we shall take that as integral 0 to infinity x into e power minus ix dx. We shall consider this, and now we will first evaluate this integral. So, for evaluating this integral, we shall put this expression as single variable Isx is equal to for this integral, say we may consider this as 1, or we may suppose this as 1, 2 and this as 3. In 3, put Isx is equal to y, and therefore, what will be x? X will be y upon Is. This is the value of x, and that dx will be equal to dy divided by Is, and therefore 3 becomes, 3 implies this f bar s is equal to integral, the limits remains the same. When x is 0, y is 0, x is infinity, y is infinity. So, integral 0 to infinity x is y upon Is, and this is e to the power minus y. Isx is y, dx is this value dy upon Is, or this we can write as a constant, can be written outside the integral, I square s square. I square is minus 1, and therefore it is minus 1 upon s square, and what remains in bracket is integral 0 to infinity e power minus y into y. That y can be written as y to the power 2 minus 1 to express it in gamma function form, and this is exactly gamma of 2. So, this is minus 1 upon s square gamma of 2, or gamma of 2 is 1 factorial, which is 1, and therefore this is minus 1 upon s square. And see, this is the value of the third integral we obtained, but actually we want to find 1 and 2, and but from LHS of 3, see, LHS of 3 we can write as, this is the RHS of 3, LHS of 3, integral 0 to infinity, it is x, and e power minus ix, we can use Euler formula for exponential and trigonometric functions, relation between. So, we have e power I theta is equal to cos theta plus I sin theta. This formula we shall use for this, and instead of theta here is minus sx. So, therefore, this is cos of minus sx is same as cos sx, and this plus I minus sx is minus sine. So, therefore, minus I sin sx using this formula. into dx. And now we can separate its real and imaginary part, and now that can be written as this is this LHS of 3 is integral 0 to infinity. 3 implies integral 0 to infinity x cos sx into dx, and this is minus I integral 0 to infinity x sin sx into dx. But this value we have obtained as minus 1 upon s square. Earlier we have obtained this. This is the right side of 3, and minus 1 by s square we can write as minus 1 upon s square real part. This is real part, and imaginary part there is no imaginary part, I into 0. And therefore now what we can do on either side, we equate real part and imaginary part. So therefore this integral is equal to minus 1 upon s square, and this integral is equal to 0. So that are the values of first and second integral. Earlier so we want sine transforms value is imaginary part is 0. So therefore this integral value is 0. That means the Fourier sine transform of x is 0. See, this is the alternative for first. And what about Fourier cosine transform of x? This is Fourier cosine transform of x, which is minus 1 upon s square. So this is minus 1 upon s square. So thus we have obtained both the answers here, Fourier sine transform and cosine transform. For this purpose we have used another integral, and we have first evaluated this integral by substitution, which is minus 1 upon s square. Then we have expressed this in this form, left side, and then we have equated real and imaginary part. So we should remember sine and cosine transform of x. Now the next one is L inverse of 1 upon s minus 4 square. There is a shifting theorem for inverse, that is these two questions remaining question, these two are for inverse Laplace transform. So we have L inverse of f of s minus a is equal to e power at L inverse of fs. This is shifting theorem for inverse Laplace transform. And now see, it is s minus a is 4. Therefore L inverse of 1 upon s minus 4 square will be e to the power, what is the value of a? This is function of s minus 4, and therefore a is 4, and that is 4t, and L inverse of s minus a is replaced by s minus 4 will be replaced by s, and that is L inverse of 1 upon s square, and that is e to the power 4t. We have by the formula for inverse Laplace transform, L inverse of 1 upon s power n plus 1 is t power n divided by n. So that means here it is t power 1 divided by 1. So using the formula, and that is t e power 4t. So this is the answer for this one, t e power 4t is the correct answer. The next one is L inverse of s minus 2. Actually here also we should use the same result for 19th problem. Using this shifting theorem, we will get L inverse of s minus 2 divided by s minus 2 square plus 5 square. Now see, s minus a, if whenever s minus a is there, we note the value of a. Here the value of a is 2, and therefore it becomes e power 2t. L inverse of, now replace this s minus a by s, means s minus 2 by s. L inverse of s divided by s square plus 5 square, and therefore it is e to the power 2t, and this is the standard formula. L inverse of s divided by s square plus 5 square is cos phi t. And thus the correct alternative is this one, B, e to the power 2t cos phi t. And the next one is the value of see, it is integral 0 to infinity x square e power minus x into dx. So that is a simple one. X square can be written as 3 minus 1 into e power minus x dx, and this is exactly gamma of 3. Gamma of 3 is 2 factorial and the value is 2. So the last integral is actually the gamma function, and gamma of 3, gamma of n plus 1 is n factorial, 1 less number factorial if it is integer, and thus the answer is for last is 2. Thus we have solved a few MCQs on integral transforms. So what is important is you should note the formulae and shifting theorems and then try to attempt these type of questions. Thank you for watching the lecture.